Hello students, in this video we'll see an example of constructing a difference quotient for the second derivative. Let's suppose that f double prime of a, the second derivative at point A, exists. And f is defined in a neighborhood of A. Let's show that the limit as h approaches 0 of f of a plus h plus f of a minus h. Now both f of a plus h and f of a minus h exist because f is defined in a neighborhood of a. So if I go a little bit beyond a to the right or left, those values are going to be defined. Minus twice f of a over h squared is equal to f double prime of a. Now, one thing we could do is if we had access to L'Hopital's rule, we could say that by L'Hopital's rule, this would be, well, if I plug in h equals 0, I have f of a plus f of a minus 2f of a. So if I plugged in h equals 0, we have f of a, negative 2f of a, that's 0 over 0. So I could use L'Hopital's rule with respect to h. This would be, our limit would be equal to the limit as h goes to 0 of the derivative of the top with respect to h, f of a plus h plus f of a minus h minus 2f of a over the derivative of the bottom with respect to h, d by dh of h squared, okay? Now let's figure out what each of these things are. So this is equal to the limit as h goes to 0, and then the derivative of this will just be f prime of a plus h. And I have to assume that f is defined, and let's also assume that f prime is also defined in those regions, okay? So, and then plus f prime of a minus h, and then the derivative of negative h is going to be a negative 1. The derivative of twice f of a with respect to h is 0 because there's no h's there, and this is all divided by a 2h. Now again, when I plug in 0, I'm going to have f prime of a and then minus f prime of a, so I get 0 on the top, 0 on the bottom, so I can use L'Hopital's rule again. So by L'Hopital's rule again, this is going to be the limit as h goes to 0 of f double prime of a plus h. And again, I'm going to have to assume now, we see what the assumptions have to be. I assume that they're defined in those neighborhoods. And then plus f double prime of a minus h. I had that original negative 1, and I have another negative 1. All over 2. And now what happens when I plug in h equals 0, what I get is I get twice f double prime of a over 2. And then this becomes what? Then this becomes just f double prime of a. So this limit exists, and this limit is equal to f double prime of a. Now what you can do is, it's a good exercise to figure out how would you derive a formula for the third derivative in terms of a difference quotient like this. You'd have to somehow get a few more terms up top, and they're going to follow a binomial expansion. So if you think carefully, a good exercise to figure out how this sort of second order difference quotient would generalize to third order, fourth order, and fifth order difference quotients. You'll probably see those in further videos too, but this is called a second order. This is a second order difference quotient. Thank you very much.